All right, so let's take a look at some problems, shall we? Let's take a look at number 12. A lot going on here. First of all, you have to recognize what factoring form this is. You guys know what factoring form this is? Yeah, difference of two cubes. And there's a couple different ways you can figure that out. One is that this thing is being cubed. Okay, you got subtraction, and then I'm sure you guys know that 125 is what number cubed? 5. So this is actually 5x cubed minus 27 is 3 cubed. So in this case, we're going to use that factor pattern that says a cubed minus b cubed equals a minus b times a squared, same opposite, plus ab plus b squared. Okay? Okay, so since a is 5x and b is 3, the first part is going to be 5x minus 3. And then what would a squared be if a is 5x? Yep, 25x squared. 5 squared is 25, x squared is x squared, okay? Then plus a times b, so multiply these two things together, you get 15x, and then plus, yes, awesome, equals 0. And there is a mnemonic device to remember this that you guys probably won't ever remember because you don't use this a ton, and that is SOAP. This sign right here is going to be the same as this sign. This one right here is always the opposite of this one. So if this is plus, then this is minus, and if this is minus, this is plus. And then the last one is always positive. So same, opposite, always positive. Anywho, so that tells us that 5x minus 3 could equal 0, or 25x squared plus 15x plus 9 could equal 0. Okay? This one is relatively easy to solve. What do you get from that? 3/5. You would add 3, divide by 5. This one, not so much. This one you need to go to the quadratic formula to solve that. What'd you say, Kate? Minus 15, which is 225. Okay. Uh-huh. Yep. Awesome. Which is 50. Okay. So you guys should all be great students like Kate and have that formula memorized like she obviously does because she was able to just know. You just have it straight out of your brain. Yeah. Okay, so then this underneath here works out to be negative 675, which then you have to break that down. That works out to be 15 times the square root of 3. Oops, we got to have an I in there because it's negative. And then all of those things are... Oh yeah, divide by 5, not answer 5, yeah. So you get uh-huh. Okay. Yeah. Anthony? Yeah. And like I said yesterday, when you're doing the sum of two cubes or the difference of two cubes, and you get this thing right here, that will never factor. Okay? So the only way that you can get the solution is by using the quadratic formula. All right? But I think we don't necessarily have to do that forward. That's kind of a lot of work. Yeah. So let's try this again with number 15. Oh. You want to do this one with the quadratic formula? Because you can factor it or you can use the quadratic formula. Which one? The quadratic what? Okay, go for it. Yep. Uh-huh. Okay. Let's see, 4 times 6 is 24, times 5 is 120, so that's 289. Uh-huh. What's the square root of 289? You don't know say either. I think 17 though, I'm going to go with. Anybody want to check that? You trust me? Trust me. Okay. So you guys could do that on your calculator. Okay, so if you do negative 13 plus 17, that is 4 divided by 12. Or you could do negative 13 minus 17, which would be negative 30 over 12. 5 half, what? 5, oh yeah, 5 halves. Yeah, okay. Oops. Okay. Yeah, the great thing about math, okay, I apologize. One of the many great things about math is that you can do the problems in lots of different ways, okay, and still come up with the same answer. So if you guys want to go quadratic formula, you can use the quadratic formula to solve any quadratic equation. So Kate's like, all I have to do is just use that formula on the board. It's super simple, okay? But you can also factor, and if you're good at factoring, this weighs a little bit. You said yours has fewer steps, but I disagree because this ended here. This ended way down here. So this only had, yeah, this is a, okay, let's take a look at number, okay, let's take a look at number 18. Hello, back up here. So this is going to be, if I do what I'm supposed to do and set it equal to 0, this is going to be a difference of 2 cubed 1 again. 8x cubed is what cubed? What number cubed is 8? 2. So this is 2x cubed minus 1 cubed. So in this case, A is 2x and B is 1. Okay? So to factor this, I would go 2x minus 1 times this thing squared, 4x squared, plus these two things multiplied together, which would be 2x, and then plus the last thing squared equals 0. Okay? What answer will this? Yeah, this would give us x equals 1/2. This one right here we would have to solve using the quadratic formula, and I'm okay if we just don't do that. Would you like to? Okay. I'd love to hear the answer. There's an I in there, I think. Okay. I square root of. Okay. Thank you. So if you use the quadratic formula, you can simplify that down to that. Okay. Okay, how far were you guys supposed to go? 24, and then we jump to some other ones. Okay, let's do number. Let's definitely do 21. Okay, 21 is a good one. Again, start by setting it equal to 0. And then even though this is an x to the fourth, can you guys recognize that we can basically just do the double parentheses with this, at least to start? And then instead of having an x and an x in the front, yeah, you would have an x squared and an x squared. Awesome. Plus or minus? Which one? One of each? Negative, negative. Yeah, they both need to be negative because I need them to multiply together to be a positive 16 and add together to be a negative 8. Okay, here's the fun part though. We can factor these. Yeah. Yeah, you can go further here. So what does x squared minus 4 factor into? Good. X plus 2, x minus 2. This is a factor pattern that you guys should pretty easily quickly start to recognize the difference of two squares. This is x squared, that's 2 squared, so plus 2 minus 2, that's a really useful one. So this time, what are my two answers? Yep, plus 2 or minus 2, they each come up twice. So this one has a multiplicity of 2, and this one also has a multiplicity of 2. Okay? Yep, I'm writing out multiplicity so you guys don't forget what that word is, but you guys can write down M2 or mult2 or something. All right, how about 24? So 24 is pretty similar to, yep, start by getting it set equal to 0. Okay, then what? Okay. Yep, it's got to be an x squared and an x squared because we need an x to the fourth this time. Two numbers that nicely done. Positive 6 and minus 2. Okay. Can I factor x squared plus 6? Two numbers that multiply together to be positive 6 and add to be 0? No, because for that to happen, they'd either both have to be positive or they both have to be negative, and then they wouldn't add up to be 0. How about, can I factor x squared minus 2? Kind of. Yeah, you know what I can factor it into is I can factor it into x minus the square root of 2 times x plus the square root of 2. Okay, I mean that's kind of weird. I'm kind of cheating a little bit because I'm throwing square roots in there. But it works. So what does x equal then? No. No. Right. Square root of 2. Or negative square root of 2. Nope, no I. Because it, yep. Okay? There would be an imaginary number if I tried to include this solution, because if I set x squared plus 6 equal to 0, I could solve that by subtracting 6 from both sides and then square rooting both sides. So x would equal the square root of negative 6 would be plus or minus I root 6. Okay? I'm not really too worried about whether you include them or not. Okay? When I mean, I know, I guess on the state test and on the college placement test that you guys will take, you'll probably have to know some stuff with imaginary numbers, but when I think about like future math classes, usually we just focus on the real solutions because, you know, they're real. Kate, no hats in the classroom. All right, then you guys jumped ahead to what? $39. All right. Kate, you want to blurt out the first step of this one too? Minus the 10x squared, yeah. So x cubed minus 10x squared plus 13x equals 0. Okay, this is a fair one. What do you do now? Factor out the x. Why aren't you? But it is now, because guess what? To factor this, you'd have to find two numbers that multiply together to equal 13 and add to be negative 10, and there aren't any. So to solve this, we have to use the quadratic formula. Okay? Before we do, though, Kate, hold on. Class, Ty, Eli, Aaron. What does x equal for this part? Yeah, so don't forget that before we dive into the quadratic formula, we do have one answer here already, that x equals 0. Okay, take it away, Kate. Yeah. Uh-huh. Nope, I want to put a 1 there. Okay. All right, 4 times 13 is what? 52? Yeah, so then if I go 100 minus 52, I get 48. Divided by 2. What is a number that you know the square root of that goes into 48 evenly? Okay, 4 works. There's a bigger one. There you go, yep, 16. So I can rewrite 48 as 16 times 3. So yeah, 10 plus or minus 4 root 3 divided by 2. And then all of those are divisible by 2, so our final answer there is 5 plus or minus 2 root 3. Okay? No, go for it. You got this, Eli. Be confident. Just pretend it's bushes. Oh. Yeah, I said that. I heard from Anthony. Was it in the driver's ed car? Oh, it was in your own car. Missed the turn, or? Oh. Yeah. Oh, we have meetings now? Okay. Yeah, if you have a meeting, go ahead and go. Okay, this is a good one. We haven't done this one yet. Flipped around. This is the sum of 2 cubes. 125x cubed is what cubed? 5x. And then 216 is what cubed? 6? Yeah, 6 times 6 is 36 times 6. 36 times, yep, okay. So that is 6 cubed. Okay, so to factor that, we would get 5x plus 6, because these two signs are always the same. And then we would do this thing squared, so that's 25x squared. This sign is going to be the opposite of that, so since this is plus, this one's going to be minus. Multiply those two together, 30x, square that, 36 equals 0. Okay? This one is an easy one to solve, or it should be. If I take 5x plus 6 and set it equal to 0, how do I solve that for x? Because it switches. Subtract 6, and then divide it by 5. So one easy answer is x equals negative 6/5. Okay? And then this one right here, you could solve using the quadratic formula. But it won't do it. It'll never factor. Yeah. It's a known mathematical thing. It'll never factor. Okay, how about 45? What can I factor out of those things, sir? No. 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 What can I factor out of those two terms? What can I factor out of those two terms? Negative 2. So if I factor negative 2 out of there, I'm left with x to the 4th. If I factor a negative out of there, this becomes a positive. Yep, and then that becomes 50, and that equals 0. Any two numbers that multiply together to be 50 and add to be 0? I don't either, because this is a plus, so that's going to... No, I have to add to be 0 because there's 0x squared in the middle. So this one actually has no, let's just leave it at that, no real solutions. I believe that's pronounced noise. Okay, how about number 48? Max is going to get excited about this one. What do I do first before I start factoring? Okay, yeah, get it all on the left, set equal to 0. And then I can factor out a x. So 5x squared minus 5x minus 12 equals 0. If Kate were here, she would do the quadratic formula, but she's not. So we're going to go a times c is negative 60. Two numbers that multiply together to be negative 60 and add to be negative 5. Uh-oh. 12 and 5, 6 and 10, 15 and 4. No, can't factor. Okay, you look for something while I do the quadratic formula. Yep, this one gives us x equals 0. Good, let's not forget that. Okay, that is 20, 240, 269. Does 269 have a... Does that have a root? What? Oh, it's 265? Oh, okay. Because this is 20, oh yeah, 240, 265. Okay, divided by 10. That does not have a square root. Is there a number that we know the square root of that goes into there evenly? 25 doesn't go in there evenly. 15, but we don't know the square root of 15. 9 doesn't go in there evenly. Okay, so I mean, that makes it easier on us, really. So there's our answers: x equals 0 or x equals 5 plus or minus the square root of 265 divided by 10. That's what you got? We go to 51 or 54? 51. 51. Well, that's okay. All right, 51. All right, we'll finish with a little word problem here. The width of a plastic storage box is 1 foot longer than the height. So the width is 1 foot. Well, we got width, length, and height. So the width is 1 foot longer than the height. Whoops. The width is 1 foot longer than the height. The length is 4 feet longer than the height. And the volume is 36 cubic feet. What are the dimensions of the box? What's the formula for the volume of a box? W times H times L. We can substitute though. Instead of using W, we can use H plus 1. Instead of using L, we can use H plus 4. And we want that to equal 36. Okay? Alright, so the first thing I'm going to do is I'm going to FOIL these two things together. H plus 1 times H plus 4. And if I do that, I get H squared plus 5H plus 4. So I need that to equal 36. Then I'm going to distribute the H. H cubed plus 5H squared plus 4H equals 36. Then I'm going to subtract 36 from both sides. And then I am going to factor, but I can't. Okay? And it's a cubic, so we can't use the quadratic formula. Sorry, Kate. So the only way that we can solve this, no, well, okay, if we wanted to solve it algebraically, there actually is a cubic formula, like there's a quadratic formula, which we could use. There's a cubic formula. I'll show you in a minute. But the easy way to do this is to solve it by graphing. So we're going to go x cubed plus 5x squared plus 4x. And then minus 36, right? Okay. And so what we're looking for is where this crosses the x-axis. Oh, that's weird. It comes out to be a whole number, huh? At 2. So maybe we could factor that somehow. Yeah, maybe if we did something earlier, you might be right. So h is equal to 2, which means that w is equal to 3, which means that L is equal 6. Yep, and if you multiply those together, 2 times 3 times 6 is 36. So we have met all of the requirements. It's a modern day miracle.